All right, we're going to analyze polynomial graphs. This is an even degree polynomial, and we're going to start focusing on some things about it. First of all, I know that it's even because even behaves like a sad or happy parabola. This one is a sad parabola. And so we can count 1, 2, 3, 4, 5 terms. If you ever figure out the terms plus 1, this will tell you the least degree polynomial it could be. So least degree would be 6. There was 5 terms plus 1. This is the least degree it could be. We know it has to be even, so it could very well be some form of a x to the 6th graph. But our job will be to analyze whether or not that was simply even or odd. So we just click this drop down, and the answer was even. But then next, if this was an x to the 6th graph, which it's not, just that, it would have a lot more to it to have all these intercepts. But to get it to point down like this, we know the a value would have to be negative based on our previous lesson. So this has got to be a negative leading coefficient. When I say a, just understand I mean leading coefficient. So that means the leading coefficient had to be negative. So we click the drop down, negative. And then it says there's how many, a blank box for how many distinct real zeros. And then it just gives you a random extra thing to focus on, in this case, maximum values. So relative maximum values. So a distinct zero means that it touches the x-axis. If it just touches, it's distinct. We're going to learn later that that's got some multiplicity there, so it kind of algebraically works out that that solution comes up twice, but we're just going to focus on this one as a single distinct. So 1, 2, 3, 4, 5 distinct zeros. And then a relative maximum value. Let's go ahead and define what a relative max or minimum value is. A relative max or min is a moment where the slope is 0 of the tangent line. So there's a calculus definition for you there. As we go up, this is positive slope, and then we would take if we just like kind of drug our pencil along, here we go, pencil, 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 and then the pencil turns sideways, and the pencil goes down, 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 and then the pencil goes sideways, and the pencil goes up, up, up. So again, this is me drawing what I can put in front of you, and then this pencil goes sideways, down, 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 sideways, up, sideways, down, down, down. Anytime the pencil goes sideways, if you are just tracking your pencil along the graph, that's a moment where the tangent line is 0. The turning point, if you will. I circled them at the beginning. These are the things to emphasize. These are your turning points. Now, any turning point is a moment where the tangent line is 0. We have either a relative max or a relative min. They're called relative extremas. Maximums are the ones where the graph is increasing to decrease. Anytime it goes increasing to decreasing, you have a relative max. So that would be these ones I'm going to circle in red. This one, and this one that I've drawn over twice. There are 3 relative maximum values. There's 2 relative minimum values, but we didn't ask about that here. I'm going to take a moment to answer about future relative minimums. A relative minimum happens whenever the graph goes decreasing to increasing. And it's hard for me not to talk about that with calculus, as I have done here with the tangent lines. The slope here on this interval goes negative and then positive, and so then that makes a minimum value. That's what we're talking about. The previous lesson we talked about intervals of increasing and decreasing. This is positive slope and then negative slope. That's increase to decrease. Positive slope is increasing, negative slope is decreasing. So that's what we're focusing on here. So let's do another one. All right, new graph, new features. This is an odd degree polynomial, and I can tell that right away because these arrows, if I connected them, look like a positive slope, like an mx plus b type of graph, a positive slope line. Any positive slope line means, and again, it's not actually mx plus b, I'm just emphasizing it's like a line. It has a positive a value, so that's a leading coefficient, and it's got an odd degree. And that's already answered a couple answers of questions down below. So we're going to click those in there. So this is odd degree. In fact, I could tell you probably what the least degree is possible. This is 1, 2, 3, 4, 5, 6 plus 1. So you count the terms plus 1. We'll tell you exactly the most likely degree. It could be more, but and so what? I forgot what I counted. So that was 6 plus 1, so 7. So 7 odd is the least possible degree. Now the leading coefficient, it was going up from left to right. So this is positive. And there are how many distinct real zeros? So we count that up. And anytime it touches the x-axis is a distinct real zero. And what's that? It's leaving room for later that we're going to have imaginary zeros, which are solutions that we'll find out later. But anyway, 1, 2, 3, 4, 5, 6 distinct zeros. And then how many relative mins? We defined earlier that a relative minimum is a turning point where we are decreasing to increasing. So we're looking for intervals of slope where it's going down to up. I'm going to clear this up so it's not so clustered. And so we're looking for the graph to go down. This is up. Now it's going down to up. Anytime you're decreasing to increasing, that is a relative min. So that's 1. Then we're going down to up again. That's 2. And we're going down to up again. That's 3. There are 3 relative minimum values. All right. That's how we discern from a graph. All right. Now, immediately my brain sees the 2 arrows pointing up. And what that means is this behaves like a parabola. Parabolas are even degree. And it's pointing up, which means it would have had a positive leading coefficient, positive a value, if you will. So that answers 2 of the questions down below. So I go ahead and click. The degree is even. In fact, I could have told you what it was. There's 1, 2, 3. Most likely that's 3 plus 1 is 4, degree 4. I clicked odd. I don't know why I clicked odd. Even. There we go. And then leading coefficient is positive. And there are how many distinct real zeros? So we just count those. 1, 2, 3, 4. So there's 4 distinct zeros. And then relative extremes. Now this time we changed. We weren't specific about what kind. Well, relative extremes are just going to be the same thing as turning points. Now, that's really limited in the scope of a real math definition. Again, a turning point is anytime you go increasing to decreasing or decreasing to increasing is what I'm talking about there. So decreasing to increasing, that's 1 turn. Increasing to decreasing, that's 2 turn. Decreasing to increasing, that's my 3rd turn. There are 3 relative extremes. That is the solution. That's all the analysis for this one. Round things out with one more example of a odd degree, because it's going down from left to right with the arrows. It looks like a negative slope line. This is an odd degree with a negative leading coefficient. And how I knew that right away is I just connected the hands, the arrows, with my mind. And then I could count the turns here and try to figure out the degree. Things get a little weird here, but it's 1, 2 turns, 3, 4, 5, 6 turns plus 1. This would have been a degree 7 in its most basic form. The lowest would have been 7. So odd degree, leading term is negative because it's going down from left to right. There are how many distinct real zeros? So then we got to look here. This slides through the x-axis. I guess I wasn't writing there. Slides through the x-axis right there. Touches again right here, right there, and right there. That is 5 distinct real zeros. And then how many minimum values does it have? Now things get a little tricky here. students are really concerned about that spot. What's happening is it's sliding through there. We have a horizontal tangent line, but then it keeps going. It's decreasing, and then it's flat, and then it's decreasing again. So what's happening there is not a minimum. It's decreasing to decreasing. So decrease and then decrease afterwards. It has to decrease and then increase afterward to get a minimum value. Yes, there is a horizontal tangent line there, but no, it is not minimum. Then right here, we do get a minimum. Everything shouldn't be red. Let's do that. Right here, we have a minimum because it goes decreasing to increasing. And then right here, it goes decreasing to increasing. So there are only two relative minimum values for this problem. With our what? Five distinct real zeros. Okay?